point and the curve. That's what we want, right? And let's just call that capital D for distance. I don't know why that D looks weird. Capital D, that's our distance. So that would be, draw me a line going to some point here. Doesn't really matter where it is. That point can be anywhere. That D represents the distance, doesn't it? I want to know where I'm going to get D to be the smallest, right? I want to minimize D. So I want to minimize D. So I'm going to need a formula for D, right? I'm going to need some equation that gives me the distance between 2 points. The distance between 2 points. Do you know the general equation for the distance between 2 points? Yeah, let's see. Let's revisit it. It's back from, I don't know, college algebra or something. If you are given 2 points in the Euclidean plane, that means on a flat sheet of paper, right? x2, y2. The shortest distance between them is a straight line. And that distance, and I'll call it little d here, is going to be the square root of x1 minus x2 squared plus y1 minus y2 squared. It doesn't matter. You could do x2 minus x1. You could do y2 minus y1. The reason it doesn't matter is because after you do that subtraction, you square it. So even if it were the other way around, the squaring would make the sign the same. Where does that come from, that formula? You just make a little right triangle, right? And then it's the hypotenuse, so you use like a squared plus b squared equals c squared. Okay, but let's get back to our picture. What is this point that's given to us, isn't it? 3, 1. So I'll call that x2, y2. What is the other point? I don't know it, do I? But it lives on that curve, doesn't it? It lives on that curve? If it lives on that curve, then there's a connection between the x and y coordinates, isn't there? How can I make the connection? Anyone know how to make this connection? If I give you an x, can you give me a y? If I give you a y, can you give me an x? Say again? Well, look, we know that this is xy, right? I mean, it's some x coordinate, some y coordinate, right? But it has to satisfy this equation, doesn't it? So could I not take this equation, and I think I want to solve it for x because it's easier, to add 1 and then divide by 4. So that means that if somebody gives me what, I can give them what? Yes, if someone gives me y, I can give them x. So you see this x right here? I can replace that x with y squared plus 1 over 4. Y squared plus 1 over 4, and then this is still y. So I have 2 points now. I have 3, 1, and I have this. Why did I just go through that step? Can anyone tell me why I just went through that step of trying to replace the x with that? With the y squared plus 1 over 4? Like, why did I do that? What if I had just left it as x and y? What would your distance formula look like? That's right. It would still have both x and y in it, wouldn't it? You'd have 2 variables. Now you're down to 1 variable. Understand? Let's look at capital D. Capital D will be the square root of x1 minus x2. So for us, what's x1? Yep, it's y squared plus 1 over 4 minus, what's x2? 3 squared plus y minus 1 squared. Any questions on that? All right. I think I'm going to start a new page here. Well, I've got room there. So the distance between those 2 points is the square root of y squared plus 1 over 4 minus 3 squared plus y minus 1 squared. Is there a restriction on y? Because now I'm ready for domain, right? Oh, I should have put d of y in the front of this, because I've got my distance in terms of a single variable. Is there a restriction on y? Is there a smallest y value and the largest y value? Look at your picture. The y-coordinate is the y-coordinate of the point along the parabola. Is there a smallest y and a biggest y? No, if I keep moving along that curve, that parabola opens up, so I could keep going up forever and down forever, right? The y-coordinate of that point. So there is no technical stopping of the y. Now, I mean, we could realistically say, hey, look, you know, it's definitely not going to be negative, right? I mean, think about it. Is the closest point from that picture have a y-coordinate that's negative? Our closest point's somewhere up here, isn't it? Like right in there? It doesn't have a negative y-coordinate. But that's because we have the picture, we can say that. If we didn't have the picture, we would have to just concede the idea that y can be anything. So I'm going to put here as a domain that basically y is any real number between negative infinity and infinity. And what is the pleasure that we all have now? A derivative, right? Chain rule. Derivative of the square root of something is 1 over square root of that junk right there. All that shit that's in there I don't feel like writing. I'm being lazy, I'm sorry. On a test, please don't put junk. Put junk when you're like an engineer or something, you're out doing work for your own company or something. You can put junk wherever you want. On a test, just write it down. Okay, times what? Oh, I forgot the 2. 1 over 2 root junk times what? The derivative of everything inside. Oh boy. Should we maybe have cleaned up the inside first, or do you just want to go after it, just try and get that derivative? We'll have to do chain rule, won't we? On each of them, because they're both squared. Right? So I'm actually going to decide to clean this. I'm going to take this real quick. I'm going to rewrite that as 1/4 y squared plus 1/4 minus 3. That is what that is, right? Dividing y squared by 4 and 1 by 4 is the same as 1/4 and 1/4. What's 1/4 take away 3? Minus 11/4, right? What am I supposed to do with that? Square it, right? So coming back to this, I'm supposed to take that and square it. So take that and square it, take that and square it. So when I square that, you do like a FOIL type thing. You get 1/16 y to the 4th. Oh man, minus 22/16 y squared. You like it or no? Plus 121 over 16. I did that mentally, so anyone concur on that? It's 11/16 twice, so that should be right. What does the other one turn out to be? What is this thing squared? Y squared minus 2y plus 1, right? We FOILed that one out. Can't I add all those together now? So what is under this root? If I were to come back here and say, oh, this is just the square root of a bunch of stuff under here, what would it be? 1/16 y to the 4th. Okay. You have to put the y squareds together. 32. Reduce that fraction. Negative 27/8 if you reduce it, or it would be, right, 54/16 or something like that. Y'all realize I'm putting these two together? Oh wait, oh I did the wrong one. Crapola, man. Glad y'all are paying attention, because I'm not, apparently. So negative 19, nope, not negative, positive, damn it. Negative 3/8. Negative 3/8 y squared. How many y's? Minus 2y, and then 1 plus that, so plus 137 over 16. Maybe the chain rule would have been better. I don't know. I just wanted to show you that you could do that. Because if I do that, then when I took that derivative, I would have 1 over 2 times root junk, right? Now times the derivative of what's inside. And that derivative is a lot easier, isn't it? No chain rule at all. What's derivative of 1/16 y to the 4th? 4/16 or 1/4 y cubed minus 3/4, I'm reducing y, minus 2. Yes or no? So where we are is 1/4 y cubed minus 3/4 y minus 2 over 2 times the square root of all that junk in there. That's our derivative.